All right, so today we're actually going to start working on learning how to use the GPS unit that we've been talking about with the actual Arduino and do some programming with it. So we're going to spend today, we're going to have a lecture that covers some basics about the library, and then there's a fairly extensive programming activity today that's going to run through all how to actually interface with the GPS and hopefully get you guys started on that. Okay, so first thing to know is, how do you install the library? Well, the easiest way to do it is actually use the library manager. And in general, if you're using a library that's in the library manager, that's the best way to do it. So you don't have to mess with manually installing, and you can also see if you have the most recent version. So if you remember, the way you do this is you select the tools menu and you hit manage libraries, and you'll get a little pop-up like this. And it's got a few drop downs for you to filter the libraries, and it's got a little search box. So what you want to do is type in Adafruit GPS and hit search, and then it should pop up this Adafruit GPS library. You want the one that says Adafruit. There's actually a few different GPS libraries for different GPS units, but this is the one for the particular piece of hardware that we're going to use. So a few things, you'll see that there is a drop down which lets you select the most recent version or select different versions. It defaults to the most recent version, and that current version right now is 1.5.4. But if you were to click that little drop down, you could pick an older version. As of right now, you should be fine with the most recent version. Obviously, we don't control the software, so there is always the potential if they could do an update, and that could potentially change the way the library works. But they haven't made any major changes like that in a while. So this is a fairly mature and stable library, so you shouldn't be too worried about it all of a sudden breaking things. So if you click that little more info thing, it'll actually take you to the GitHub repository. So if you remember when we first talked about programming, there was version control systems, and GitHub is basically a public repository that you can use for version control. So it's a site that basically hosts a bunch of coding projects, and if you wanted to, you could make your own. So you could just click on the actual link either. So that more info will take you to this website, and that's the actual repository. So you could install that manually, and the way that you do that is you'll get there'll be a link to download a zip file. And what you have to do is you have to copy that into your sketchbook libraries folder. And if you remember, you can actually set the sketchbook folder in the preferences. By default, on a Windows computer, that'll be, documents, Arduino, and then libraries. But, you may change that, and I'm not sure, on a Mac, exactly where it gets put. So like I said, right now, the most recent version is 1.5.4. So that's the one you want. There's no reason to go with an older version as of now. So there's a few things to note to make sure that you have the library installed. If it's something that you've installed by the library manager, when you open the library manager up, it should now have this little green text that says installed, if it was correctly installed. Also, if you open the file menu and go to examples, you should be able to scroll down and find examples because this library does include examples. And you should also be able to use the sketch menu and the include library option and have it automatically add the include statement to the top of your library. So the way that you actually, if you remember, the way we include libraries is we use this pound sign, number sign, hashtag, whatever you want to call it, include, and then within these braces, the little pointy brackets, you include the name of the .h file for the library. So for this case, it should be Adafruit _GPS.h. So if the library is installed correctly and you have typed the name of the library incorrectly, it should look like this here, where the text is orange. So this, the yellow background is because I had it highlighted. But the important thing to look for is that orange text. If it's not orange, that means that either you've got the name of the library incorrect, or maybe it's not installed properly for one reason or another. Maybe you put the folder in the wrong spot. But if it's actually installed correctly, you get the IDE will recognize like the keywords, and basically it'll be able to see the stuff inside the library and know that, okay, yep, this is an actual library, I recognize it. The other thing that you'll see is we will be able to declare a new, so this is going to add a new variable type. So like integer, like float, like all of those built-in types, this is going to add a type called the Adafruit GPS type. And so again, if it's correctly installed, when I try and declare a variable of that type, it'll show up orange like that. So just going back to general communication with the GPS, the way that this works is we talk to the GPS and we receive its data all through ASCII text strings. So these are sent over the UART, over the serial that you have the GPS connected to. If I have the switch in the little switch on the GPS unit in direct, remember, it's going to connect to serial 0, the TX and RX 0 pin. If I have it in that soft serial position, it should come out to those jumpers that you should have installed, and then it'll go to wherever you have those connected to. Usually what we do for most of the examples here, we're going to use serial 1, which is TX and RX 1, but there's no reason that you have to do that. You could use serial 2 or serial 3. Just obviously your code would need to be slightly different. So since this is a serial or UART protocol, that means it has a baud rate. The default baud rate for the GPS is 9600. So we're going to talk about some of the commands for the GPS, and one of the commands that you could do is you could change that baud rate, but that's not something we usually do. So the general output from the GPS is going to be those NEMA sentences that we talked about. So and it's just going to output those automatically without any input, without any prompting, because that's how it's designed. And if you have this open on the serial monitor, because remember, if we have the switch in the direct connect, it will be transmitting on our USB port, so we will be able to look at it on the serial monitor. And it'll just output strings like this, right? So you can see this is just a picture of the serial monitor with a bunch of sentences being output. So in general, right, it's going to look like those NEMA sentences that we covered previously. So depending on which sentences are on, those will all be transmitted. In particular, as just a quick example, right, this and the example in this text box, this was taken from on August 15th of 2019. So you may be able to spot the time there, time and date there, except that there was no fix. So you can see that basically this just has a bunch of commas with no data in a lot of spots. And that's because the GPS did not have a fix at the point that screenshot was taken. So what are these strings that we use for input and output? In general, like we said, the output is the NEMA sentences. It has, I believe, 6 different possible sentences that you can turn on, and it will output those sentences at some automatic rate. By default, the 4 sentences that are on are the GGA, the GSA, the RMC, and the VTG sentences. So basically, whenever we're working with this GPS, you're going to want to have the NEMA sentence reference at least available so you can quickly access it. Because, you know, I don't remember what data is on all of those different sentences. I do remember that in general, the ones you need are the GGA and the RMC. But if you need to be like, hey, I need this data, you know, we've got the link to all the different sentences on the website as a PDF you can download. And like I said, it's going to transmit those sentences at an automatic rate. So by default, it will send all of the sentences every second. So it'll transmit them at the top of the second. It will do that for however long it takes to send the data it needs to at the baud rate, and then it'll wait for the next second and sit there. So like with the sentences and some of the other things, that's something you can change. An output rate at once a second is pretty good, and that's pretty useful, but you can change that. I believe the maximum value is you can have it output as low as once every 10 seconds, and then as quickly as transmitting it every 10th of a second. In addition to the NEMA sentences, there are certain commands that, well, any command is going to be acknowledged by the GPS, and it'll return an acknowledge string back to tell you that it got the command. In addition, there are certain commands where you can basically ask the status of some of the settings. And obviously in those cases, you basically query, hey, what sentences are on, and it has to give you an output back. So those are the other responses that you can get out of the GPS other than the NEMA sentences. The actual input strings, the commands that we keep talking about, are also basically pre-formatted text strings. They look very similar to the NEMA sentences. They are called PMTK packets. And I believe that's pretty much just because of the company that made this hardware is called MediaTek. and the P either stands for protocol or packet, right? And just for reference, there is a full list of commands. So basically all the possible commands that you could send to this thing available on that PDF. So the way that we actually handle this thing in software is, like I said, we have a new variable type called Adafruit GPS. And this is going to be, so this is what you would maybe call an object. So this is like a more complicated variable type. It's a variable type that basically has its own predefined functions that you can call on it. And one thing that we have to do when we declare this variable type is we have to tell it which serial port that it's going to be connected to. So you can see I have two lines here. This first one, I'm just basically declaring that GPS serial is the same thing for serial 1. So everywhere in code where after this where I have GPS serial, it's going to, the compiler is actually going to substitute serial 1 when it runs. So this allows me to just call anywhere that I want, just say GPS serial, and then I don't have, if I decide to change it, I can just change it in this one spot. And I don't have to remember, okay, which serial port did I connect the GPS to every time I want. And then the actual variable declaration is down here. So again, it's Adafruit GPS is the type. My name here is GPS. And then what I'm actually doing here is, this is what's called, those of you familiar with programming, this is something that's called a pointer. But basically what I'm saying is, rather than giving it the actual serial variable, I'm just sending it the memory address of the serial object. And that just happens to be the way this particular library works, is you don't send GPS serial or serial 1. You have to actually send it this ampersand serial 1 or ampersand GPS serial. And that is basically going to set up this GPS variable as attached to serial 1. So once we've created this object, we can now call functions that are specific to that to do operations. So, and the way this is going to work in general is you're going to have the name of the variable. So we're using GPS here, a period or dot, and then the actual function after that. And that's basically telling it, run this function that is defined for this particular type of variable on that instance of the variable. So I could have more than one GPSs. I would need to give them different names. And then I would call like GPS1 send command or GPS2 send command if I had multiple. In this case, I just have one. So it's going to run this send command function on this particular object, which is our GPS object. So here's a few very useful GPS functions that you're gonna definitely need to use. So the first one is, how do I actually send this thing commands? Well, I use the send command function, and the argument that you put inside the parentheses here is going to be the actual command string, those PMTK strings that we mentioned. And we'll take a look at what those strings actually look like a little bit later. And And then the other important one is the read function. And this one doesn't actually take an argument. What this is going to do is it's going to read a single character out of the GPS serial buffer. It will return it, but most of the time we don't need to worry about that character that's returned, because the other thing that this does is it copies that character into a running NEMA sentence that it's building up. So just by calling that read function, it's going to append that character to an internal variable where the library is building up the NEMA sentence. So another function is going to give us the last completed NEMA function that the library got. So as it builds up that sentence, it will eventually be able to tell that it has a complete sentence, a complete NEMA sentence. So not like just the first 5 characters, the whole sentence from the $ to the last character. And if I call this last NEMA function, it will return the string that is that entire text string that is the GPS or the last NEMA that it completed.
Just the one sentence, like the last sentence.
So the question is, yeah, was that the last sentence? So yeah, whatever the last complete NEMA sentence that it got will be returned there, not the one that it's currently building up, because you basically have 2. So there's one where it's currently adding characters to, and then the last one that it completed. So last NEMA will give you the last one that was finished. So then you may ask, well, how do I know if it has actually completed a NEMA sentence? Well, there's a function that returns a true or false. So this is going to be a Boolean function. And then that basically tells you, has a new NEMA sentence been completed since the last time you called last NEMA? Or if you haven't ever called last NEMA in the program, that'll tell you when, if a complete NEMA sentence has been available. And then finally, you have the parse function. So all of these sentences have a bunch of different pieces of data in them. And you could manually go in and break up the data and pull the pieces out that you need. But conveniently, the library has this function. So you have to give it the NEMA sentence. So we're usually going to have GPS.parse. And then inside the parentheses, we'll usually have GPS last NEMA. And what that'll do is the library will then look at that sentence, pull all of the individual pieces of data. So this parse function will basically take whatever NEMA sentence you feed it, and then it'll update a bunch of internal variables that are part of this GPS object. So that way we can then access those internal variables to get the specific latitude or longitude or altitude without having to go through the entire text string and find the piece of data that we want. All right. So in general, the way that this data works is the GPS just automatically outputs to whichever Arduino serial port that it's connected to. And it's going to output all of the sentences that it's currently set up to output. And it's not going to have like a pause or a gap in between them. So it's just going to output all of those characters one after another. Those are going to be read in. So since we have this connected to one of the hardware serial ports, the Arduino is going to automatically copy those into one of those hardware buffers that we've talked about. Because the hardware serials basically have a dedicated piece of memory and dedicated hardware that will copy those characters in. On the Arduino, the Mega, those buffers are 64 characters long. So if we don't read the characters out of that buffer before the 65th character is added, we're going to lose that data because it's going to basically overwrite the old character with that 65th character. So when we call gps.read, it's going to pull whatever is the next character out of that buffer. It'll free up that space in the buffer. It will return that character to us if we need to do anything with that character, but usually we're just going to, we're not going to do anything with the single character. It then does 3 things. It will copy that character into the current NEMA sentence that it's building up. And then it will check and see if that character was a new line character, because the last character of a NEMA sentence is a new line character. And that's how it tells that it's just finished a NEMA sentence. It says, oh, I just got a new line character. Now the current NEMA sentence is complete. When that happens, it will copy the one that it was building up into last NEMA. So if I haven't read in last NEMA and done anything with that old one, that gets lost. It will then flip new NEMA received to be true, and then it will create a new current NEMA sentence that it's going to start building. So and the next time that I call gps.read, that character will be added to that new current NEMA sentence. And the one that I had just been building up is now last NEMA. And that's what I'll get when I call last NEMA. So this means that we need to be concerned basically about how quickly we're reading this data in and how much time is going to happen in between, because a lot of that stuff happens automatically and there's limited memory space for all of that data. If we sort of ignore it, it'll get overwritten and we'll miss data. So in general, I could read out, and by read, I mean call gps.read 2 different ways. And those are called polling and interrupts. Polling would be where I basically just put gps.read somewhere in my loop, my loop function. So that means basically every time I get to that part of the loop function, I would go see if there's a character available to read. The problem with that is I may have my program may be busy doing other stuff, or I may not want to just constantly be checking the serial port because I want to do other stuff with my program. Instead, the way that you want to call your read functions is with an interrupt. So basically, an interrupt is when you have a specific hardware signal that's going to basically pause the execution of the program, and it'll go run a specific bit of code every time it gets that interrupt signal. And while it has not gotten that interrupt signal, it'll just keep running its normal, the normal code in the loop. So this is basically a function that is not anywhere in your loop, but there's some trigger that will cause it to occur. So that specific trigger can be a few different things. It can be a signal on a pin. So I could have a interrupt that gets flipped, that occurs every time like a pin goes from low to high. Or another very useful thing is there are hardware timers on the Arduino, and I can set it up so that some of those timers will trigger an interrupt. And that's actually going to be how we're going to suggest you do your reads. And we're going to show you the code how to set that up. So this is what that code looks like. So there's actually two functions here. We have this signal function up top, and this is actually the function that gets called on the interrupt. So this is what's called an interrupt service routine. And you may actually see, instead of signal, you may see ISR. The thing inside the parentheses here, where it's timer 0 underscore comp A underscore vect, that is the actual signal that triggers this interrupt. And what this actually is it's basically a triggering. So timer 0 is one of those internal timers, and comp A is basically, there's another register that it will compare the value in this timer to, and when they match, this particular thing this signal will get triggered. And all that we're doing in the interrupt service routine is calling GPS.read. I mean, we're sticking it in this character C, but you can see that we're not returning this character. One, because there's not really a way to return things from interrupt service routines, right? Because I don't call this function anywhere. It just happens on its own. So that individual character gets dropped, but the GPS.read copies that character to that NEMA sentence that we're building. And in particular, timer 0 is the timer that generates the ticks for millis. So if you use millis for timing, every millisecond, millis will increment by 1. So that means if I am firing this routine every time that particular counter, which rolls over every millisecond, if I'm matching a particular value and that timer resets every millisecond, I'll basically be calling this function once every millisecond. So this means that every millisecond, I will try and read a character, which is fast enough that, right, because I have 64 characters, I'm only sending, like 30 or so characters once every second. This means I'll be able to read in all of my characters, regardless of what else is going on in my program, because if I use this, my program will pause, it'll go read a character and then return back to what it's doing. This second function here is a function that we actually declare. So by default, this signal is not on. So this is basically a function that we're going to use to be able to turn this interrupt on and off. So you can see that it takes this Boolean argument. So when I pass it true, it's going to turn the interrupt on. When I pass it false, it's going to turn the interrupt off. So this little block of code here is what actually turns the interrupt on, and this is the one that turns it off. The easy thing to understand here is just setting this using interrupt variable to true or false. So this is a global variable that we're going to have in our program that basically lets us check, is the interrupt on or off. That actually has nothing to do with turning it on, the interrupt on and off. That just lets us by checking the value of that variable, I can see which state I'm in. This line here, and honestly, this is a little bit technical, and you guys probably don't need to worry about how this works, but you do want to basically use this code. this is basically setting the value that it's going to match timer 0 to, and then the next line below that Tim SK0, that's what actually turns that interrupt on or off. That's basically a masking signal, and when it has a particular value, it masks that interrupt signal on, or it masks it off. So, but like we said, this is an important chunk of code, and this is sort of the way we recommend you read out the actual GPS. So now I want to just cover the basic structure of the actual commands. So like I said, it's a string of characters similar to the NEMA sentence. So it's going to start with a $sign and end with a carriage return and a line feed. But instead of like GP, GLL, or any of that, all of the commands are going to have first this string PMTK, which tells the GPS that it's a command, that you're trying to send a command to it. It will then be followed by 3 numbers. So always 3 digits. So even if you're trying to send a 1, it'll be 001. A 10 will be 010, right? And that set of numbers tells the GPS what command you're trying to send it. So then there will be a comma. And then this chunk in here is what's different depending on which command you're sending. So this is what actually tells the GPS what you want it to do based on which command it is. Usually this is going to be a bunch of values separated by commas. And what you have to do is look at the command reference and be like, okay, if I want to turn these sentences on, I need, this string of numbers. And then finally, you've got this, there'll be a star and then 2 characters, which is the checksum. So just like the GPS NEMA sentences, this is going to end in a checksum. So where that's the hex value of the checksum. And then you have the 2 end line characters indicating the end of transmission. Now, you can do this all manually, where basically you would use GPS, send command, and then in quotes, because it is a character string, you type out the full command. So that would look something like this in your code. You would have GPS.send command and then da 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 da. So this particular command turns off all of the NEMA sentences except GLL. Now, one, that requires you to look through the command, that big command PDF. You have to go in and figure out, okay, how do I need this? What command do I need? What are the individual pieces of data that I need? And then you also you'll have to use something, you'll have to calculate this checksum, because if you don't send the right checksum, this won't get executed correctly. And that is, obviously very tedious and a lot harder to do. So instead, the library basically has inside of it a file where it has declared a bunch of constants for several useful commands. And that way you can just put the constant instead inside the parentheses, and then it will send that command string. So in particular, so all of the constants are going to start with this PMTK, and then they are usually named in a way that is more logical so that you can look at what the constant is and figure out what it does. So this constant here is the same thing as this entire string here. It sets the NEMA output to be GLL only, right? It's a lot easier to be, okay, I need GLL only, rather than trying to figure out what all the individual values are and then what checksum you need. So in general, this is going to be the way you're going to send commands to the GPS. You'll use these constants that are defined in the library. So one thing to note is anytime you send a command, you will get a acknowledgement string back from the GPS. That will be returned pretty much immediately. So that's not going to get transmitted. It's not going to wait for the next set of NEMA sentences. If you send it during the time when it's transmitting a bunch of NEMA sentences, it will add that on the end. So it won't like screw up one of the NEMA sentences by transmitting it in the middle, but it will send that next. And that will get read in. And when you do like a last NEMA, if that was the last thing it received, that's what you'll get. So one particular thing that we have run into flying these GPS units, and this is somewhat still of a mystery to us here, is we've had some of these GPS shields basically like cap out at an altitude around at 10,000 feet. And basically what we've seen is the data from the GPS stops updating once it gets above 10,000 feet. The annoying thing is this only seems to happen some of the time. And these GPS units are supposed to work above that altitude. So after doing a bunch of digging around into the data sheets, we found that there is a version of this unit that has like a navigation mode select. So it has like basically like ground mode, pedestrian mode, car mode, aircraft mode, and most importantly, it has a balloon mode. And the big difference that we can tell in those modes is all of those other modes have a maximum altitude of 10 kilometers. But this balloon mode has a maximum altitude of 80 kilometers, which is well above the height that we're going to fly to. One of the reasons it took us so long to figure this out is there's nothing in any of the Adafruit documentation or the library documentation about this particular command. It's not one of the predefined ones. I basically had to go digging around to the manufacturer's specs, and I found a version that had this command listed. So basically, as part of your setup, we're recommending you run this particular command, so this string right here, and that should ensure that the GPS is in balloon mode and hopefully prevent this altitude lockup from happening. And an important thing to remember is the GPS, once it loses power, unless you have that coin cell in, it's going to return to all of the factory defaults. So in general, what you want to do is in your setup function, you have a block of code where you set all of the settings that you want for the GPS, so that every time that it loses power, you reset the GPS to the configuration to what you want. So one important caveat is using the parsing, the automatic parsing. All of those updates only happen when you call the parse function on the NEMA sentence. So that means if you aren't calling the parse function on a NEMA sentence that has that particular data in it, like for example, the date is not in all of the functions, that's not going to get updated, and it's going to either use the default values if you've never called the parse function on a sentence that has that data, or it'll be the old data. So for example, is if I sorry, what was I trying? So if I have only, if I called the parse function on something, on a sentence that had an altitude, but then I wait a bunch of times and I only call the parse function on sentences that don't have the altitude, when I try and use the internal variable that has altitude, which is like this, gps.altitude, I'll get that old altitude value. But in general, it's a lot easier to use these parse functions. So the way that these work is you call parse on the sentence, it will pull all the individual pieces of data out of that and update the internal variables. So if I had called it on something that had altitude, like the GGA, and in that NEMA sentence, it had the value 302 meters for the altitude, when I call gps.altitude, I will get the value 300.2. But again, one, you need a fix to get that data into the NEMA sentences. And then you also have to call the parse on the appropriate NEMA sentence string. So this is a useful list, a table. These are not all of those little internal variables that you can use, but these are the most common ones. And one thing I would point out is there's actually two different latitude and longitudes, because the format of the latitude and longitude, there's a couple of common ways. So in particular, the raw output of the GPS is in this format. So it'll have basically numbers before the decimal and then numbers after. But what it'll be is, it will be first the degrees, and then it'll be minutes, and then decimal minutes, right? So there are 60 minutes in a degree. So that means if I wanted to convert these numbers into decimal degrees, I would need to basically take this first part and get that number and then divide the rest of it by 60 and add it. But conveniently, the library will do that operation. So you can just read in, call these two different variables, and that will give you the value in decimal degrees. Then you also, so you have, what you would expect. You have hours, minutes, seconds, days, months, years to give you a timestamp. There is the number of satellites that you have a lock. That's something that's very useful to monitor for troubleshooting, especially if you're starting to have an issue. And then there is actually a one that will tell you what kind of fix you have. So one thing to note is these are not functions, right? You don't have the parentheses. These are just these are variables that have the value. It's just the GPS library is what does all the overriding of those variables. So that's sort of it for the intro to the library, the library lecture.